Well, hi, good morning. Thank you for joining me in my shop here today. It's now July 17th. Holy smokes. Time keeps on marching. So, the last video I posted was a crazy time for me in the shop here. Just goes to show you that this kind of work can be very humbling to the point of near humiliation. No, I don't feel humiliated, but definitely things were a little unnecessarily complicated yesterday. So today, do I want to get into more complications, do more alignment work? No. I think today what I'm going to do is I'm going to test all the tubes in the radio. The thinking here on my part is I've checked the IF tuning. The intermediate stage tuning is good. Most of the gain in these radios comes in the IF, especially the IF amplifier tube. If the IF is tuned well, but the radio is still weak, I think it is, you have to turn the volume way up to get it to do something. It's not on right now. Then I think that implicates, is certainly a good possibility is the tube is bad. So I'm going to test them all here, one at a time, of course. And I shouldn't go too crazy doing it. Let's start right with the rectifier tube. Now, I can't imagine the rectifier tube is in trouble, but let's find out. Well, I don't see the tube name here. Sometimes you have to look very, very close. It takes a bit of time to spot it. Well, it's there's no hint of the number on the tube here. Let me just check the tube base. Sometimes they mark it on the base too. No. Okay. Well, based on the schematic, or some information somewhere, it is a 5Y4. It certainly looks like a 5Y4. 5Y3 looks pretty much the same though. Let's take a look here. I don't believe you can exchange either of those tubes, one for the other. Okay, I'm going to get this set up. I have to make get the video working properly too, and we'll test that tube. Okay, first tube here. Now let me just double check this. 5Y4, so the filament voltage is 5 volts. The numbers are 0030P, 0030P, and 0760, 0760, 25E. Very good. Now this tube should show a short during the short test when the short test is moved over to setting number 1. That's normal. Okay, let's get the short test. There's the short showing up. No problem. Okay, so this is a rectifier tube, so I'm pushing the rectifier button, looking for this to come up above where my finger is now, up in this area. It's good. Now there's two and one here. Both show good. Okay, that's the first tube done. No problem. Okay, ready on the output tube, 6F6. Double checking it. 6F6. No question about it. Okay, 6F6 is this line here. Using my shadow to underline the so 6.3, signal level 2, bias 46H. H must stand for high. The numbers are 27345, 27345, 0610, 0610, 45. Whoop, whoop, whoop. I got something different there. 34. 34. And F on the plate. There we go. I'll hold this near the microphone and do what you see me doing right now. And I don't think you heard a thing. Whatever was loose in here stopped being loose. Often there's stuff loose in the space, in the base here, between the base plastic and the glass bulb, which extends down into it a little bit. And there can be stuff in there. There's still something rattling around a little bit. Or it could be right in the glass globe. I have tubes with parts that come loose inside the tube itself and have fallen around inside. Hard to believe that that can happen. Okay, in this case there should be no shorts showing up during this test. No shorts. Okay, we're going to measure the mutual or transconductance, whatever word you like for it, and the reject point for this tube is 830. So if it can't get above where my finger's pointing, you could sell this guy a new tube. That's how it used to be. Here we go. Oh, it's well above. It's well above. So the output tube, which I was quite suspicious of, is not the cause of the low volume in the radio. It's got to be something else. I was going to pick the detector tube next, but have a look. This is the one where somebody previously soldered the tube base down to the chassis. This is not a good idea. So we can look into some other alternative to do this, but I'm going to skip this tube for now and go on. I'm going to go on to this one down here. And what tube is that? That is a, I don't know yet. Yes, I do. Isn't this the 6J5? And read down here, USA 6J5. Right there. Okay, I'll set this up for the 6J5. Okay, let's do the double checking here. 6J5, 6.3 filament volts, 2 signal level, 18 H the bias, 27305, 27305, 0610, 0610, 28, and F. We're good. This pin 1 here, I believe, is connected to the shell, the metal shell. And this is where you'd want to make a connection, not solder to the side of a tube like this. Now, a couple of these tubes, I think on this radio, I won't say it. Yeah, I won't finish what I was going to say. Because it's not true. Remember these words of wisdom now I will lend to you, and you can keep them as long as you want. You can lend them to other people too. You cannot be manipulated with the truth. People can't get you to do what they want with the truth. Well, maybe they can, but in that case it would be okay. Generally, if people are trying to get you to do something, they don't tell you the truth. There you are. That's my words of wisdom. Somebody trying to get you to do something? Maybe trying to get you to vote a certain way? Okay, enough of that nonsense. Here we go. Any shorts in this tube? There are not. Again, this one's very similar to the last one in terms of what number it has to come up to. 840. Here we go. Way over. she's a beauty. Okay, I have to fish out another tube to test here. Okay, let's check into the situation with this tube. So, anybody who did this didn't realize what pin 1 is probably doing. So if we look back here, and we try to spot pin number 1, where's a pointer? Okay, I'll use this. Pin number 1. Pin number 1 is right here. See, in this socket, there isn't even, so this is why he soldered it. There's no terminal. Hello? Yes, this is Joe. Oh, right. Uh-huh. Yeah. Okay, phone call kind of threw me off there. So, no pin here. So what to do? So what the other fella did was he decided to solder it right on here. Wow. It might be better to solder to the pin here. Or, well, I can't test the tube while it's soldered. I have to unsolder it no matter what. How I put it back, I can decide later. Okay. Big job for a small soldering iron here. Too big a job. Can heat it up there. Let's try this piece. Suddenly. Jeepers. There we go. Come on out of there. Boy, oh boy, what a fighter. 6K7. Okay, that was exciting, wasn't it? 6K7. Okay, let me set this up and we'll give it a shot. Okay, 6K7, 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 6 volts, 2 signal level 33L, bias 17342, 17342, 0610, 0610, 43. D. Whoops. I got that wrong. Very good. We don't want to get this wrong. We got to put on a grid cap. Grid cap connector. There we go. What's it say about it? It just says grid cap, doesn't say anything more. 1070, so a good tube is just going to come up past this 1000 mark where my finger is. Okay, short check. No shorts. Here we go. Oh, very good. having trouble finding a weak tube here. It's kind of a good thing, but kind of not a good thing at the same time. Okay, let me get the next tube out. So I'm going to check and see if I'm correct about pin number 1. Pin number 1, this pin here. A little spot. I got my finger right on it. A little spot they cleared off here to solder to. That's what I have to touch. Nothing. Make sure that's pin number 1. There we go. So I think what I'll do is I will solder a small wire onto pin number 1 here. Just a wire about that long. When I plug it in, the wire will stick out, and I'll just attach the wire to this spot and not try to solder back to the body of the tube. I think that's a tough one there. A lot easier to solder onto these pins. Okay, I'm going to leave it out for now, and we're going to move on to the next tube, which is a little difficult tube. No, maybe not. Okay, it's in a... I got to take all this off. There's 2 more tubes to do. Well, okay, let's carry on with the one. I'll put this back in here so I don't get confused. This guy. So typically these are just pushed on, these cans. And it's just a matter of pulling them off. Just pull them right off. Just pull it right off. Good boy. Let's try wedging it. Or prying it a bit here. Yeah, that's better. There we are. Okay. It's been a little funny business with the cap here. It's been resoldered. So these caps, the actual clip part, is steel. And it's steel, so it's springy, so it'll clamp onto the top here. You can't solder to steel. So the wire is crimped into these connectors, and that crimp can cause problems. And then later, when you try to solder it, you can't solder it because it's steel. That's probably why there's a little bit of wire coming out. No, it looks like somebody managed to solder that. Okay, enough of that. 6K5. Okay, 6K5. Let's test it. I'll get the tube tester ready to go. Well, it turns out my tube tester will do a 6K4 and a 6K6, but a 6K5 is not in the list. Definitely a 6K5, and I just looked at my tube book. There it is, 6K5. IMU triode. I gotta get a different tube tester out here to test this tube. Okay. Okay, this is my Stark 966. It's a really well-known tube tester. Certainly here in Canada, I think it was extremely popular. Okay, 966. Oh, I better look and see if it doesn't. Of course, I have another chart for this one too. So we're looking for a 6K5. 6K5. down here. 6D, 6J, 6K, 6K5. There we are. 6K5. So filament voltage 6.3. And the settings are J, R, 03070. 03070. 03070. 03070. Okay. Yeah, bias is set to 21. 21. The roll chart keeps rolling. 49 for the English. Almost there. Press P4. Cap. I gotta put on a grid cap. Oh. Where's the wire? Oh no. You have to fish a wire out of there. Uh-oh. Yeah, you know what? I don't know what's happened to the little wire I had extended out of here. You see what's happened is the little fitting here broke on this one and everything fell into the tube tester, and I had a wire extension coming up and I was using that. The wire extension has disappeared. The piece is down there, it's flopping around. I don't want to operate this tube tester. I got to get at this grid thing. It's a hassle. And guess what? Tube tester week is coming. In a few weeks, or at some point in the not too distant future, I'll be doing a week of tube testers here. I'll be going through all my tube testers and verifying their operation and all that kind of stuff, and fixing out little deficiencies that may have occurred. I'll fix this at that time. Okay, I need another tube tester here. And one, oh man, it's turning into yesterday. Okay, let's give this guy a try. Now this one is not as good as the last two. This uses a different technique for testing tubes. So this one is called an emissions tester. The last two testers can measure the amplification capability of a tube. This one can't. What this one does though is it measures the amount of current going through the tube, and from that you can judge the condition of the tube. And it's really quite reliable. You just can't actually measure the transconductance. So there are better and worse tube testers of this sort. This is a better for sure. So first we want to set the voltage here. So now this just has click settings. What's going on here? Oh, my video is frozen. So it's just possible clicking this switch, yes, the one my hand is still on, has interrupted the camera here, oddly enough. Let's just try this. you never know where the excitement's coming from. There we are. When you're in my shop. From this, let's try it again. I don't know what happened there. Okay. So we want to test, now can this even do a 6K5? This is a very old tube compared to this tube tester. It may not go back far enough. 6K. 6K5. There it is. 6K5. Okay, so 6.3. Love the big knobs on here. A123. A123. And the other line is A49. A49. The big dial is set to 25. And when we go to test, we push these two buttons simultaneously for the test. What about the grid cap? What about it? Here it is. Okay, I'll grab the tube. Here. Pop the grid cap on. There we are. So there's only this tube and one other tube. That could be at fault here. Okay, you can see the heaters come on the tube. First test is a short test indicated by this neon light. There we go. Cathode, plate, grid 2, I don't think there is one. Grid 1. No shorts appearing. Okay, so the test now was W685 WX. WX. Wow, okay, what do you make of that? So it's testing here weak. And it's not far off. Let's just do a little sensitivity. What if I just move this knob? See this knob just a little wee bit? So that, the calibration of this unit's a little off, and maybe this knob shouldn't be 25, it should be 28, and now it's in the good. So you can see it's a little bit questionable about how accurate this really is. The tube works, it appears to be weak. Perhaps I can find a metal version of a 6K5. Gee, I don't know. That would be good. So if it's possible, this is quieting the radio, this tube. Because you really rather have it come up in the 80, 90, 100 range up in here. Okay, so this is a possibility. Definitely a possibility. And now we have one more tube to do. Put this back in its socket. Okay, one more tube. I'm just going to pull it out here. We'll use the same tube tester. And wrestling. And out it comes. 6A8. Okay, 6A8. The thing about this tube tester is very fast. And if you just want to know if a tube is working, at all, this is a great one for it. So here we are. So we push these two end buttons here to release the others. Release the buttons. 1, 2, 3, 6, 8. 1, 2, 3, 6, and 8. And 4, 5, 9. 4, 5, and 9. 18 on the big knob. I'm the big knob. Okay. There we go. 6.3, of course. As a tube gets older, the surface of the cathode wears off. So depending upon how hard the tube's been working, how much current it's been passing during its life, and how many hours of operation, obviously. As the cathode wears off, the ability of the tube to conduct current gets worse and worse, and that's the principle of this tube tester. It's looking for worn out cathodes or serious problems like broken elements or heater not working, that kind of stuff. Otherwise, it's a cathode checker, really, I think. Okay, we do a WX on this. WX. She's in the good, but there's 2 tests for this tube. So I'm going to pull it out while I set the switches. Release the switches. 1, 2, 3, 4, 5. Wow, I can't get that wrong. 1, 2, 3, 4, 5. AC68. AC68. 38. The big wheel. Okay, back in we go. This time it's X and Z. X and Z. Give it a moment. Okay, any shorts in there? I'm not looking at the light. Look at the light. Too many tube testers in my life. Got another one coming in a day or two. X and Z. Here we go. Okay. 6A8 testing bad here. Now that was very low. This could easily be the guy. Now it's not telling me what it is we're testing. There's diodes in here and there's a triode. And it's not telling me which is which of the test. So we're going to do this tube again in one of the other tube testers because I know they'll do a 6A8. Okay, we're ready here. 6A8. 6A8. Signal level 1. 20L. 27345. 27345. 4610. 4610. 32 C. Okay, grid cap. So this tester is not like the last one. This is one of the ones that will actually test the amplification factor. I hate to use that word. It's not really true, but kind of true. That's what it's kind of measuring. Where it's sensitive to the ability of the tube to amplify. It does that by measuring a factor. It's a ratio of the input voltage, the out, and the tube current. And you work this ratio and you come up with something called transconductance or mutual conductance. And there's various other terms that are used for this effect, including negative resistance. Sometimes it's referred to as negative resistance. Okay, let's see what this guy says. Now, it's only one test, unfortunately, in this tube tester. It's one test testing the whole thing. So in the other tube tester did them in 2 sections, and one came good, one came bad. So what's the average going to be? The average might show up good. So let's find out. I'm ready to go. 750 is what it says. Just above where my thumb is there. So way high. This tester is saying she's good. The other tester is saying half of it's bad. I need to bring out another tube tester. I'm going to have to work on my other one. Another tube tester. Oh my gosh. Okay, I got to think about that for another tube tester, really? Okay, so I pulled out my precision tube tester. This is probably the best tube tester I actually have. It's not quite a laboratory tube tester, but it has more functions or features, I guess, than your average tube tester. I can measure filament current, which is an important thing that the other tube testers don't go near. The problem here is I can't remember how to use this, so I'm going to stop for a while, kind of refresh my memory on how to set this whole thing up. And the tube I'm using is a grid cap. Here we are, grid. Good. Just need something to plug in there. Okay, so I'm going to do that. Familiarize myself with the beast. Okay, feeling a little shaky about using this because I know it's complicated. Plug it in here. Now, it's got 3 tests for this tube. It's a two-part tube with 3 tests. I mean, you can't read what's written in there. Oh, maybe if I do this. Well, you'll never be able to read the small print here. I'm having trouble reading. 3 tests. How come 3 tests in a two-part tube? One of the tests is an emissions test. The other 2 are probably measuring the transconductance. So first test, here we go, checking the numbers. So 6.3 on the heater voltage, and then VG, it doesn't matter. VG, this one doesn't matter. Next one is 06432. Let's see, 06432. Okay, next one is 05210. 05210. Now, the next thing it says is 1 volt. And what it's telling me is what the bias needs to be set to. So the bias adjustment is here, and you do that by setting the meter to bias. And you adjust this for 1 volt on the bias scale. Where's the bias scale on here? This is, here's the bias scale. At 1 volt, just right there, next to nowhere. 1 volt. You can check the line voltage here and adjust it there. And you can also read the current flow through the tube. If I flip it like this, the meter will show us current. Where's the current scale? Filament amps is this right inside scale. There's 2 scales. There's a 0.3 and a 3 amp. It starts with the 3 amp one. So we would start probably with plugging the tube in and then setting the bias. Probably how we're going to do this. Okay, I can also do the line adjust, but the tube needs to be in to do the line adjust. Where's the on-off switch up here? Off. Life test on. Okay, so we got it on. There we go. And I have a grid cap thing I can put in here. Put that on the grid. Okay. This is the reason I don't use this tester is exactly this. It's complicated to use. It's slow, but it's much closer to a laboratory device. 688. Here you go. 6.3. Here you go. Don't fall over. Go in here. Okay. So next thing is setting the bias to 1 volt. So we set the meter to show bias. There's the bias indication, and it's right around 1 volt. Oh my gosh, it's kind of weird how this works. Is that all? Am I reading this right? Well, anyway, that's 1 volt on the bias scale. This is, oh, there's a bias setting here. So I could flip it to 50. Yeah, something not quite right here. But I'm getting the 1 volt I need right there. I had to replace this bias control if I remember right. Maybe something's happened. Maybe I got the test. Son of a gun. Maybe I'm doing the test wrong. Stay on there. Line voltage check. It's showing 0. And it's supposed to come up in the middle. Once again, I'm just not experienced enough. Don't know why the meter just fell to nothing. Line voltage check. Okay, tube current check. Well, a lot of things are not working out here. Am I doing something wrong? I think you have to throw this into test. That wouldn't be the line though. So there's a spring-loaded test and a hold test. Hold test. Hold on, back off. Stop. Stop. We haven't done the shorts test. Okay, we're going to do shorts test. And I believe it says here 2 and 7 should show shorts. And the short indicator light, where are you? short indicator lights there. 2, yep. 7, yep. Those are the heater. Ooh, short on 9. Short on 9. Well, that's a little tricky. There's only 8 pins. How do you get a short on 9? There are even 8 pins. I don't know what to think of that. You know, it's feeling more and more like yesterday. The craziness is just starting to pour in on me. Well, the other two testers did not show a short. This one shows a short on number 9. How can that even matter? Put it on the test setting. We're on the test setting. We should get a test reading right now. No, I gotta throw this. Test reading. The meter went backwards. The meter went backwards. Yeah, I don't... Yeah, there's something bad going on here. It's another flop. It's another flop. Well, the alternative here is just go back to the tube tester, get an alternate, 6A8, stick it in, see if it holds up on the second test, whereas this one failed, and then put the better tube in the radio and go from there. Because I think I'm just beating my head against the wall here doing this. Maybe one more check just to see. Maybe I got something set wrong. I can find it. Here, don't quit too soon. BGAG. BGAG. Yes. 06432. 06432. 05210. 05210. 1 volt bias. Well, I think there's 1 volt bias there. The reading is supposed to be basically 1,000 on the meter. And this meter is complicated to read also. You got to pay attention to what scale you're on here. If I remember right. Maybe I don't remember right. Yeah, I'm getting nowhere here. We're getting nowhere. It's a nice tube tester, but too complicated for just the casual use. I'm a casual tube tester. Okay, so these are mostly 6A8 tubes in here, and they've been tested, at least to make sure they pass a rudimentary test. Number 9 is one of the better ones. If I can find the tube with the number 9 on it, then we will try that one. Yeah, well, almost any of these tubes will do though. You see 9. Here's 8. 9 must be right near it. 13. 10. 1. Oh, I got this all mixed up. 3. Going the wrong way. 1. 9. I thought this would just take 2. I thought this would just take a second. They're all over the map here. Who's been in my tubes? Who's done this? There's number 9. Okay. So previously this tube tested very good. Let's see what happens here. Number 9. This is definitely a 6A8. I didn't put the sticker right on the thing, did I? I wouldn't do that. A little bit of paint on it. Well, somehow I determined this to be a 6A8 before. So we will go with it and find out. Well, we'll know soon enough. If it really fails the test, it's not a 6A8. Put this one in. This one here, and I want to put this with the radio as the original. Okay, because I have a way of getting these things mixed up. Okay, so this is the same test. Better do the short test first. Okay, same test. The last tube failed this test, and I believe I'm pushing X and Z. So that one, you see it? It kind of jumped into the good a little bit. So it's a little better. We better do the other test. So 1, 2, 3, 6, 8. 1, 2, 3, 6, and 8. 4, 5, 9. 4, 5, 9. This is an easy tube tester to use. It's pretty fast. 18. WX. So the other tube tested way down here, which is very bad. This one tests on the other test, just into the good. Now let's swap it. We'll see what happens. Good. Swap it in the radio. What we're trying to do is achieve better volume coming out of the radio. It's not terrible. Like it's workable, but you have to have the volume knob turned up quite high on this radio. So we're going to put this guy in. I'll leave the sticker on it so I can't get too confused. Put that over here. So tube testers do not operate the vacuum tubes the way they're going to be operated in a radio. It's not like that. Hey, where's the good cap? Here it is. The tube testers have their own way of operating things. I'm going to run this tube without the ground deal done. Well, we can make temporary connections to do a little experimenting here if we really want to see what happens. If you don't ground this, it may not be the end of the world. So whoops, closer to the front of the radio may be more important. I don't know. I'd have to do experiments to find out. Okay, before I turn the set on, I think I got to clean up the bench a little bit here, so I'm going to stop for a moment. So unfortunately, this is just a subjective test based on my memory of how well this radio worked, which isn't really the best way to do this. But I have an outside antenna connected. Now it's connected. We'll see what happens here. So I've put the shield back on this tube. But this one is running without its ground connection that somebody had soldered. We will see what happens to that. Volume's right down. Everything seems fine, so we'll hit the full power. Look over here. Okay, moment of truth. We're on the broadcast band. What do we hear? The volume way up to get there. Now, this may not be the fairest test, but let's go. Can't call that much of an improvement. Hey, radio, you're not working at all again. Ooh, so that could be from lack of shielding over here. Time to experiment. Gotta put a ground on that. Right. Okay. Let's spin this around. Can I just do something very, very clumsily here? Ooh. Hello. Hello, everybody. Okay, that answers that question. We have to deal with the grounding here. I mean, the guy did this for good reasons, but I just think there's a better way to do it. So we're going to switch off the power. Okay, I'm going to deal with that too, but you know, it's getting very late in the morning. My gosh. My gosh. So this tube, the rectifier tube as usual, is very hot. Never touch the glass tube on a rectifier tube. Okay, so my plan here is to attach a wire to pin number 1. Wait a minute. This is pin number 1. Just bring it out a bit, and I'll be able to connect it to this piece there. That's what I'm going to do. So I'm trying to solder that wire as close to the base of the tube as possible, or it's going to interfere with the tube settling down in the socket. You don't want to put too much heat on for too long. You could break the connection inside the pin. It's not likely, but it's possible. Don't need a lot of stuff here. Get on there. Get on there. Oh, I think I got it. Oh, I moved it too soon. Tell me. That solder came up the pin. It's going to interfere a bit, but it'll go far enough in, I'm pretty sure. Okay, so now we just need it to come out a little bit. Is pin 1 anywhere near where we want it? Good question. Let's see. So pin 1 is here, I think. So it's way on the far side. Okay. Now did that just break the solder there? Nope. It's good. Good. So we need it here. This will freak somebody out somewhere down the road. They'll see this and wonder what is going on there. Let me just solder it onto this very handy ground spot the last guy created. Oh my gosh. Yeah, because I'm doing these videos essentially live, from time to time I have the camera aimed wrong and stuff like that. If you've been watching my videos, you know that kind of stuff happens. Because my primary thing here is not making a video. Primary thing is fixing this radio. Yeah, if the primary thing were making videos, they would look a lot different. There we go. Just solder that in. Whoops. Soldering iron. So that puts a ground on pin 1. And that's exactly what pin 1 is for in these metal cans. Metal tubes. Metal canned tubes. So I'll get rid of that problem. And probably not having this grounded change the operating conditions for the tube. Which is why maybe we didn't really receive anything much until I stuck the ground on it. Okay, here we go. Once again, we'll give it another try. Okay, so now I've done something to that tube, so we need to watch the dim bulbs. Behavior is normal, so I did not short the plate or do something dumb like that. Yep, all looks good. Full power. So we're still on broadcast. Long ways to go to get some volume. Let's try the shortwave band. Might be a little better. Okay, we'll go looking for that station at 9. Around here. Where is it? Not happening. So this time of day you would expect signals at higher frequency. 11. I'm really going to do this slow. And it's receiving. Oh my gosh, what is that? Oh, we got some bad behavior in here now. How come? How come you're doing that? Oh boy, did I forget something? Let's make it squeal. Well, that's it for today. I wonder if, by some chance, this tube has got changed also and needs the ground pin to be grounded, and it isn't. I wonder if that's possible. Sure looks possible. So maybe that's the deal, because when I was moving this and touching it, the squeal was changing its pitch. It could be all kinds of things besides that, but that's a disappointing ending. Guess they're just it's another case of you better leave well enough alone. I feel like I'm sliding downwards here a little bit. Thanks a lot for watching today. It's another kind of crazy video, and tomorrow we'll just kind of deal with this situation, try to sort out what it is. Is it because I put that other tube in? Is it because now the radio works better and so its better operation is revealing more problems? I don't know the answer to that. Okay, we'll see you tomorrow. Bye.